We are going to look at the cyanohydrin formation from aldehyde or a ketone. This is almost exactly the same mechanism as the base catalyzed hydration of an aldehyde or ketone. The only difference here is the base. That's it. Everything else about this mechanism is exactly the same. So you can watch these two side by side and you will note that they are exactly the same. The only thing that is different is that you add cyanide instead of hydroxide. So we're going to use a ketone. I'm not going to make it a very complicated ketone. And on your arrow, what you're going to do is have a 1-2 kind of a reaction. First off, you're going to add sodium cyanide. It's very important that it's sodium cyanide. If it was hydrogen cyanide, HCN, that's a weak acid and it tends to not dissociate really. And if it doesn't dissociate, you haven't got a cyanide present. So it is important that you introduce it as the ion. And usually we add this in something like diethyl ether. After it has been added, then we add acid. And usually at that point you can add HCl because the point is just to protonate it. And that might be dissolved in a little bit of water or something like that. But these might be typical reaction conditions that you would see. And this would be like having a hydroxide in water, the same type of conditions there. So what happens here is that you have an aldehyde or a ketone in solution with this cyanide ion. The sodium is a spectator. It will not participate in the reaction. Now it's the carbon that has the negative charge, not the nitrogen. If you can't remember that, look at the formal charges. Carbon has the formal charge of -1, nitrogen is 0. So make sure it's the carbon that you add, not the nitrogen. But the carbon will act as the nucleophile and add to the carbonyl carbon the same as the hydroxide did. Now as that happens, you cannot have 5 bonds to carbon, so the carbon-oxygen pi bond breaks because it's the weaker of the 4 bonds. And oxygen is more electronegative, so it will take the electrons. As this happens, we'll make these tetrahedral intermediates again. You're going to make an alkoxide intermediate. This is your intermediate, and this is where it will literally stay after the first step. It will go no further. It would be paired up with the sodium ion as its cation. Okay? It has nowhere else to go. The second step, we add the acid in this case. So we're going to add hydrochloric acid. Now, HCl is a strong acid, so it is a proton source. There's a proton available, and the oxygen needs a proton, so you pick it up. And when you're done, we make the cyanohydrin. Cyano because of the carbon-nitrogen triple bond, hydrin because it's hydrated, it's got an OH group on there. This looks almost exactly like the hydrate. The only difference here is what was added, this CN group instead of an OH group. It's exactly the same mechanism. So if you need to, take a look at that again and note that this is exactly the same. Overall, we have added HCN.